Good morning, students. Welcome back to maths class in the chapter vectors. Okay, last session we have to study the first introduction part. Next is directed line segment. Directed line segment types of vectors. To over. Next, today we have to discuss position vector of a point. 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 First, we have to consider the three-dimension space. Consider a three-dimension space, right-handed system, rectangular coordinate axis. Rectangular coordinate axis. Consider a three-dimension space, right-handed rectangular coordinate system. Okay, x, y, z with respect to the origin. Consider a point P. Consider a point P in space of the coordinates x, y, z. X, y, z with respect to the origin. With respect to the origin, O of 0, 0, 0 with respect to the origin. Okay. Then the vector OP vector, then the OP vector R vector, R vector. Okay, with O as its initial point, O as its initial point, okay, and P as its terminal point. E is initial point and P as its terminal point. Terminal point is called the position vector of the point P. Is called the position vector of the point P with respect to O. With respect to O. Okay. Like this condition. Consider a three-dimension space. Consider a three-dimension space. Three-dimension space. Right-handed rectangular coordinate axis. Okay. Next, point P. Consider a point P in space. Consider a point. Consider a point. Consider a point in space having coordinates x, y, z. X, y, z with respect to the origin. With respect to the origin. O of 0, 0, 0. O of 0, 0, 0. Then the vector OP vector, then the vector OP vector R vector. OP vector or R vector with the vector OP vector or R vector with O as its initial point and P as its terminal point. Terminal point is called the position vector. Position vector of the point P. Position vector of the point P with respect to origin O. With respect to origin. Okay. This is position vector of a point OP with respect to origin. OP vector is equal to R vector. Next is by distance formula. By distance formula, you know this distance formula between 2 points. AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. By distance formula, the magnitude of OP vector R vector. The magnitude of OP vector, position vector, okay, OP vector R vector is given by magnitude of OP vector or magnitude of R vector. Okay, magnitude of AB vector or magnitude of A vector. Magnitude of A vector can be written as A only. Magnitude of R vector is R. Root of OP AB. Okay, O point is 0 0 0. P point is x y z. Okay, now x2 minus x1 whole square. x2 is what? X. OP. This is x1, y1, z1. This point is x2, y2, z2. AB using distance formula. AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. 3-dimension space consider. Okay, x minus 0 whole square x square plus y minus 0 whole square y square plus z minus 0 whole square z square. Okay, this is magnitude of OP vector. Magnitude of OP vector R vector is equal to root of x square plus y square plus z square. Okay, next is you have to find, we denote the position vector. We denote the position vectors of any points A, B, C. Any points A, B, C A, B, C, etc. With respect to the origin, O, okay, origin O denote the A vector, B vector, C vector respectively. Okay, note the vectors A vector, B vector, C vector respectively. In this figure, X, Y, Z. Okay. A, B, C. Position vector OA vector is A vector. Position vector OB vector is equal to B vector. Position vector OC is equal to C vector. Okay, this means we denote the position vectors of any points A, B, C, etc. respectively. With respect to the origin node, denote the A vector, B vector, C vector respectively. That is, OA vector is equal to A vector. OA vector is equal to A vector. Position vector OA is what? A vector. Position vector OB is B vector. And OC vector is equal to C vector. Okay, this is position vector of any points A, B, C, D. Okay, OD is equal to a small d vector. Okay, this is totally position vector of a point. Next is to discuss the problems exercise 10.1. Next is exercise 10.1 problems. First question: represent a represent represent graphically a displacement of 40 kilometer 30 degree east of north. Okay, represent graphically a displacement of 40 kilometer 30 degree east of north. Right, graphically. Okay, solution. That is east, north, west, south. Okay. Question is graphically a displacement of 40 kilometer 30 degree east of north. We have to take scale. We have to take 10 kilometer. 40 kilometer is a 10 kilometer. Okay. First, then you have to take. We denote the first displacement is 30 degree east of north. Okay. We have to take displacement 30 degree east of. The displacement is 30 degree. Displacement is 30 degree east of north. 30 degree east of north. Okay, we have to take 30 degree east of north. Okay, this is P. OP, the vector OP vector represents the displacement of 40 kilometer 30 degree east of north. We have to draw. We have to draw. We have to draw a straight line. Draw a straight line, making 30 degree with north. With north. Okay. Therefore, here the vector OP vector, the vector OP vector, the vector OP vector represents the vector OP vector. Okay, this is 40 kilometer. Okay, the vector OP vector represents the displacement displacement of displacement of 40 kilometer 30 degree east of north. Okay, first we have to draw this one graphically: east, north, west, south. Okay, first is displacement is what? 30 degree east of north. Okay, now taking scale 10 kilometer, 10, 20, 40. Yeah, approximately. Next is we have to draw a straight line. Okay, making a 30 degree with north. Okay, now we have to mention the vector OP represents the displacement of 40 kilometer 30 degree east of north. Okay, this is the solution. Next, another question, same one, same, represent graphically a displacement of 40 kilometer 30 degree west of south. Same procedure. Okay, west of south. This one. Okay, same procedure. West of south. 40 kilometer, 30 degrees. Check it, this one. Represent graphically a displacement of 40 kilometer, 30 degree west of south. In this one. Okay, west of south. This one 30 degree. Same OP vector represents the 40 kilometer west of 30 degree west of south. Next question. Third one. Classify the following. Measures as scalars. Sign vectors. First one, 5 seconds. 5 seconds. Second one, 1000 cm cube. Third one, 1000 centimeter per cubic centimeter. Third one, 10 Newton. 10 Newton. Fourth one, 30 kilometer per hour. 30 kilometer per hour. Next, fifth one, 10 gram per centimeter. Cubic centimeter. Sixth one, 20 meter per second. 20 meter per second towards north. Towards north. Towards north. Okay. You know this already scalar sign vectors. Scalar is what? Having magnitude but no direction. Vector is what? Vector is a quantity that has both magnitude and direction. Check it. First one, 5 seconds. 5 seconds. This is what? Time. 5 seconds. Okay. It involves only magnitude but no direction. Okay. This is what? Scalar. This is what? Scalar. This one is what? This unit is value. Cubic centimeter. Cubic centimeter. This one is value. Value is what? Scalar. Value is scalar. Next is 10 Newton. Unit is force. Force is what? Vector. It involves both magnitude and direction. Magnitude means what? Absolute number. Only number. This one. 5 seconds. Time. This one is what? Time. Time is a scalar. Then this one is value. Value is a scalar. Next is 10 Newton. This one is what? You need force. Force is what? Vector. Next is kilometer per hour. Speed. This one is what? Speed. This means scalar. This is only number, scalar. Next is 10 gram per cm cube. Cubic centimeter. Okay, this is what? Density. Okay, this one is density. Density is a scalar. Density is a scalar. Density is a scalar. Okay. Next question. 20 meter per second towards north. Towards north. Towards north. This one is velocity. Okay. Meter per second. Velocity. Velocity is vector. Velocity is what? Vector. Okay. Classify the following measures as scalar sign vectors. 5 seconds. This is scalar because speed and time. Next is 1000 cubic centimeter. That is value. Cubic is value. That is scalar. 10 Newton force. This is vector. It involves both magnitude and direction. Kilometer per hour. This is speed. Length number. Okay, speed is scalar. Density is scalar. Gram per cubic centimeter. This is density. Is what? Scalar. Next 20 meter per second towards north. This is velocity. Is vector. Next question. Same one. Classify the following measures as scalar sign vectors. Fourth one, classify the following measures as scalar sign vectors. Same first one, 10 kg. 10 kg. Second one, 2 meters, 2 meters north to south, north to west, north to west. Okay. Third one, 40 degree, 40 degree. Fourth one, 40 watt. Fifth one, 10 power minus 19 coulomb. Coulomb. Sixth one, 20 meter per second square. 20 meter per second square. Okay. First one, 10 kg. 10 kg. This is what weight. Only it was only magnitude. This one is scalar. This means weight. Weight is scalar. Weight is scalar. Okay, 10 kg is what? Scalar. Next is 2 meters north to west. North to west. This is what? Displacement. It involves both magnitude and direction. Displacement. Displacement is vector. Both it involves both magnitude and direction. 40 degree. This is what? Temperature. Temperature is what? Temperature is scalar. Is scalar. Okay. Next, 40 watt. Watt. Voltage. This one is what? Voltage. Voltage is what? Scalar. Voltage is scalar. Voltage is scalar. Okay. Next is no. First one 10 kg. Weight. No. This is weight is vector. Weight is vector. It involves both magnitude and direction. Okay, weight, magnitude and direction. 10 kg is weight is vector. 10 power minus 19 is coulomb. Minus 19 coulomb. This is scalar. Okay, it involves both magnitude and direction. Meter per second square. So it is acceleration. Okay, acceleration. Acceleration is scalar, vector. It involves both magnitude and direction. 20 meter per second square is acceleration. Okay, meter per second square is acceleration. Is what? Vector. It involves both magnitude and direction. First one, correction that 10 kg is weight. Weight is what? Vector. It involves both magnitude and direction is there. Both. Okay, this 10 kg is vector. 10 kg is what? Vector. Next, another one, same question. What? Classify the following measures as scalar sign vectors. Next question. First one, time period. Time period. Second, distance. Second, distance. Third one, velocity. Fourth one, work done. Fifth one, force. Okay. These are the very simple this one. Time period, distance, directly work. This one. Velocity, work done, force. Time period is scalar, distance is also scalar. This one is velocity. This one is both magnitude and direction involves. Involves work done, involves only magnitude. This one is scalar. Force is involves both magnitude and direction. This is vector. Okay. Next questions. In figure, which of the vectors, which of the vectors are, which of the vectors are in figure? Okay. Okay. A vector, this one is C vector, this one is B vector, this one is D vector. Direction is this one. Okay. In figure, which of the vectors are? First one, collinear, collinear. Second one, equal, equal. Third one is co-initial, 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 co-initial. Okay, already given the diagram. Okay, given vectors are, which of the vectors are collinear? Collinear means what? Already I am telling you last session. Two vectors are said to be collinear if they are parallel to the same line. If they are parallel to the same line, okay, irrespective of their magnitude and direction, that is scalar. Sorry, that is collinear. Next, equal vectors are what? Equal vectors are two vectors are said to be equal. Here vectors. Tell me in this figure solution. Collinear vectors are first one. Collinear vectors are collinear vectors are parallel to the same line. A and C are parallel, parallel to the same line. In this line, another vector is what? D. A, C, D are the collinear vectors parallel to the same line with respect to their magnitude and directions. Okay. Okay, direction same level ಬಿಡ್ಲಿ ಒಂದೇ ಲೈನ್ ಮೇಲೆ ಇದೆ okay A vector, C vector and D vector. A, C and D vectors are what? Collinear vectors parallel to the same line. Parallel to the same line. These two lines are what? Collinear, parallel. This vector is A, this vector is C, this vector is D. Okay, A, C, D are the collinear vectors. Next, second, equal vectors. Equal vectors are equal vectors are what? Two vectors are said to be equal if they are what? If they are the same magnitude and directions, both same magnitude and directions. This one same direction, A and C are same directions. This one is opposite direction, B is what? Opposite directions. This one also different. Okay, A and C are what? Equal vectors. A and C vectors are equal vectors because same directions. Both are same directions. Third one, coinitial. Coinitial vectors are same initial point B, C, D. Okay, this will directions. Okay, same initial point. I'm telling that having same initial point. This is A, B, B vector. This is A vector. Okay, OA vector and OB vector are coinitial vectors with as its what? Initial point. Whereas it has initial point. OA vector and OB vector are what? Co-initial vector. In this figure, co-initial vectors are B vector, C vector, D vector. B, C, and D are the co-initial vectors. This is given diagram. You have to tell that collinear, equal, and coinitial. Okay, this is the answer. Next, another question, same one. In figure, which of the identify the in figure square is there given square diagram. Identify the following. Identify the following vectors. First one, co-initial. Second one, equal. Third one, collinear but not equal. Collinear but not equal. Figure A vector, B vector, C vector. This one is D vector. Okay, first one, co-initial vectors. Co-initial vectors. Co-initial vectors are co-initial vectors means, and I am telling, same initial point. Same initial point. A vector and C, A and D vector are co-initial vectors. Same initial point. Starting point is same. Second, equal vectors. Equal vectors are equal vectors, same directions. Same directions. A, C are what? Opposite directions. B and D are what? Same directions. B and D are same directions. B vector and D vector are equal vectors. Third one, observe that collinear but not equal. Collinear but not parallel to the same line. Parallel to the same line. Okay, parallel to the same line is what? Not equal. Don't take B and D. These are what? Directions are same. Then not the magnitude is not equal. You are taking A and C are the A vector and C vectors are collinear vectors but not equal. They are parallel. Their directions are not same. Directions are not same. A and C are A vector and C vector are collinear but not equal. A and C are not equal vectors because okay, different opposite directions A and C okay are not equal. But not equal because okay they are parallel. They are what? Parallel. They are parallel and what? Opposite directions. And opposite directions. Their directions are not same. And they are and directions their directions are not same. Directions are not same. Okay, not equal. Only collinear vectors. These are what? Directions are same. These are equal vectors. Don't take. A and C are the collinear vectors, but not equal. Okay. Last question. Answer the following. Answer the following as true or false. True or false. Some statements are given. Tell me that true or false. First one. A vector and negative of a vector are collinear. Okay, A vector and minus A vector are collinear. Is true or false? Okay, this one A vector, this one negative of a vector, opposite direction. This is negative of a vector. These two vectors are collinear. Yes, parallel to the same line. This one. This is what? 2. Is 2. Second, two collinear vectors. Two collinear vectors are always equal in magnitude. Equal in magnitude. Okay, this is second. If two collinear vectors are always equal in magnitude. You know this definition, collinear vectors, if they are parallel to the same line, in respect to their magnitude and direction, okay, parallel to the same line, then need not to be equal in magnitude. Okay, this is false. This one is false. This one is false. This one parallel to the same line, need not to be equal in magnitude. That is false. Two collinear vectors are always equal in magnitude. Is what? False. Third one. Two vectors having same magnitude are collinear. Okay, it is not necessary for two vectors having same magnitude. Okay, this means collinear is what? Parallel to the same line. Okay, this is also false. This means it is not necessary for two vectors having same magnitude. This means parallel to the same line. This means. Okay, third one, fourth one, last. Two collinear vectors having the same magnitude are equal. Two vectors are said to be equal if they have the same magnitude and direction. First, to observe two collinear vectors have the same magnitude are equal. Equal vectors are what? If they have the same magnitude and directions. Okay. Collinear vectors are what? Parallel to the same line. Need not to be equal in same in magnitude. This is also false. Okay. Two collinear vectors having the same magnitude are equal. Two vectors are said to be equal if they have the same magnitude and directions. Collinear vectors having same parallel to the same line need not to be equal. This is false. Okay, first one, a vector and negative of a vector are collinear. This is true. This is obviously true. Parallel to the same line. Parallel to the same line. Second one is two vectors. Two collinear vectors are always equal in magnitude. Collinear vectors are what? Parallel to the same line, but they need not to be equal in magnitude. They need not to be equal in magnitude. That is false. Third one, two vectors having the same magnitude are collinear. It is necessary for two vectors having the same magnitude. Same magnitude, but they are parallel to the same need not to be. This one also same. Two collinear vectors having the same magnitude are equal means two vectors are said to be equal if they are the same magnitude and directions. Parallel to the same line need not to be equal. This is also false. Okay, thank you. Tomorrow we'll continue the class.